Hello and welcome to this talk on building bulletproof APIs with Java. I would like to share with you 5 features that I would like to see in production-ready APIs that, based on my experiences with building them, with using APIs, and general best practices out there. Um, First of all, a few words about myself. My name is Rustam Mehmandarov. I'm a principal engineer and a cloud lead in Miles here in Norway. I'm also a Java champion, Google Developer Expert on Cloud, Docker Captain, Oracle Ace, and quite often I speak at events, at conferences, and also organize quite a few of them as well. So back to the topic at hand. So what we would like to talk about here is how to build production grade APIs, and also with production grade APIs based on Jakarta EE 11, MicroProfile, and with zero vendor lock-in as well. You can find most of those features in any other uh, uh, frameworks or even languages that you might be using, but this examples and stuff here will be based on Jakarta EE 11. And well, you might know it as a Java EE, J2EE, and all those things. This is Jakarta is the evolution of all those things and improvement of all those things that you have probably have heard of from previous years. Very often we see at the conferences, we see talks where you just go with the hello world and you just do a very simple demo with a post and get and a little bit of parameters and everything, and then you're done, right? This is not how we build production environments. This is not how we build an enterprise software. So there are very often some gaps. There are gaps related to validation, to observability, to security, to versioning, and to error handling, and those kind of things. And this is exactly what we'll be talking about here as well. We will also talk about not putting your business logic into the code to make it easier to understand, easier to maintain, easier to generally get an idea of what's happening in that code as well. My point here is that Jakarta EE and MicroProfile is enough to build. It has all those building steps or building blocks to build those kind of APIs, and that's what I want to show you here as well. Like I promised, we'll talk at we'll talk about and look at 5 different features or parts. One I called for gatekeepers. That's all about filtering. We'll look into that in a second. Security part, something I called a lens, where we talk about observability and health and probes and stuff like that. We'll talk about the contract, so something and everything related to OpenAPI specs and all these kind of things. And lastly, something I called for evolution. That's where we talk about versioning of your APIs and how to make sure that you can provide different versions and different versions of objects based on specific techniques to do the versioning. At the end, a little bonus, I'll also show you a few examples on how to do error handling. A lot of this code that you will see on the screen is taken from a repository where both this presentation and the code are put together. It's a public repository that I'll share the link with you at the end of this talk, where you can have a look at the presentation, at the code, build it, run it, and test it for yourself. So first of all, we need some kind of domain, right, for this demo. A very simple domain, since we're at a conference and we talk about conferences and we talk about APIs, so why not just create something I call for a conference API. So you have a session, you have some speakers connected to that session, you have some rooms connected to that session, and this is pretty much it. It has a few IDs, a few names, and all these kind of things connected to it. Typical examples you can see at the bottom. You'll have some speakers, you have some sessions, and some kind of description of rooms. It's simple to have it in a talk, but it's still complex enough to show some of the complexities that I'll be talking in this while demonstrating these 5 patterns, right? So first of all, gatekeepers. So gatekeepers is, without gatekeepers, well, you will end up putting a lot of your business logic and all these kind of things inside your application. And this is where you will end up putting all those ifs and else's and handling of authorization and roles and, handling error codes and all these things. It's kind of complicated. It gets very, very hard to manage very quickly, right? With gatekeepers, you can write very small, tiny little pieces of code that will do exactly what you want. And you can also separate that logic of handling roles or handling error codes and all these things, different classes that make it easier to understand, to maintain, and so on, so on, so on. Right? So let's talk about the filter chain. So typical filter chain when using Jakarta EE, you can do it in this way. You can do some, you can annotate things with at pre-matching that will be run before any URI matching at all. So you can do all the handling of things that you might want to do there. You can do also sanitization interceptors. So for example, clean your requests bodies from possible HTML tags, JavaScript tags. If you're running some kind of LLM at the end, you can also use it to do some simple prompt injection handling and stuff like that. Maybe that's something you want to do somewhere else. I have a very different talk, very different repository and everything that explains and goes into depth on that topic, but we're not talking about LLMs at this session this time. So then you can also add things to audit your application. So to be able to audit your application, where you can log things, you can log how long things take time, or who is doing what and what is being done and what kind of responses and everything that has been received, right? At the end, you can also provide bean validation with some ready annotations that come with that, but also you can create your own. So like the example that we'll see here is this no profanity tag that I've created. So you can, for example, remove unwanted words from talks, bios, and session names and room names and all these kind of things where it might appear. And at the end, you have a clean input that you actually can handle, right? So, which is very nice. And each layer is a standard Jakarta EE API thing, and you don't need any framework magic to do that, which is kind of nice, right? So let's have a look at sanitization of your code. This can look something like this. You have a few patterns where you recognize HTML tags or JavaScript things, and then you can actually remove those, for example, right? And like I said, all the code is in the same repository as this presentation, so you can actually click on different classes, have a look at them, examine them, and actually go back to the presentation, which is really nice to learn and understand this kind of features as well. Due to the format of this presentation, I have to keep it very short, so I will not be able to go into too much of demos and details, but hopefully there will be another opportunity to do a longer depth session, but in the meantime, you can use the repository and explore things yourself. When we talk about audit logging, we can also do things like that. So you can create your own audited tag, and you can say, well, I want to what kind of target it has and what has to be done, and then I can use that on my endpoints as an audit filter. For example, here I'm actually creating log entries with audit, so I override the two filters. As you can see, one of them is being run before anything happens and the other one is happening after. Very useful thing to log who's doing what, when it's things happening, and also for example how long things take time as well. Right. And here you can also see different versions of session resources. So there is a session resource v1, v2, speaker resource, and so on. And all of them have this audited tag on it that are logging things. So you can have a look at how things happening inside the code. Room resource, not annotated, and that's a kind of an important thing to notice. So since it's not annotated, it's not going to be audited, or any audit logs or filters will be applied to it. So no annotation, no filtering, no audit things kicking in. So you can also choose which ones you want to audit and which ones you don't need to. Right. So custom validators. So like I said, we created one that's called no profanity. That is looking for those specific 3 words. I mean, there could be different words, but in this case, we just decided to go with something relatively simple and safe without putting any other words on the screen, right? So you can create your own error messages. You can create your own um, for example, message like this, which will default to text contains prohibited content. And that's it, right? For example, so we can block stuff coming in. You can also combine it with the existing ones that are like a part of the bean validation thing, which load blank and size and so on, so on, so on, right? So how it all connects together, if you want to put all those things and all those gatekeepers together, it will be something like this, right? How you will have a client request coming in, it will go through sanitization filter, sanitization interceptor, audit filter, and now it comes into this bean validation thing, right? So this is where the bean validation is happening for the things that we've seen. For example, no profanity, or should not be empty, and so on, so on, right? And then you can also do exception handling here as well. So if it fails, you can invoke a specific exception that will be mapped to a specific HTTP error code and return to the user, which is very, very nice. We'll have a look at that all the way at the end of this presentation. So at valid runs at method entry, and it's managed by bean validation, again by Jakarta EE. Exception mapper will run afterwards and also managed by JAX-RS, but also it will give you an information and map it to correct error codes and stuff like that. It's pretty cool. Kind of catch them all features that you'll see at the end as well. So a little spoiler here. So the second feature, in addition to filters and is to secure your applications. So securing your applications is relatively easy, but it also demands quite a bit of understanding of how to build tokens, how the JW tokens are working and all that. But when you still need that, I mean, you still need to understand what's going on and how you build that. And if you want to do that, you can have a look again at this repository, which builds a very simple, it provides some simple shell scripts and stuff to build those tokens. But once you have them, because normally they will be handled for you by your ops team or your API integration team or API gateway team and stuff like that. But once you have them, you can quite easily do it inside your code. Things like declaring roles, providing which roles can run as specific endpoints, or you can also say, for example, this can be run by everybody. And you can also provide the keys and everything as a properties files inside your application. So pretty easy way of handling all this with a very little code, but again, it needs a little bit of understanding. You can also do role-based access control here as well. So here you can do, for example, say, you know what, this endpoint has to be open for everyone, so permit all, and this one has to be run only by organizers, and so on, so on, so on, right? So for example, here you have a public read for everything, for everyone, and then you have also write requests and delete requests are all only can be handled by organizers, for example, right? Yeah, the annotation is the policy, and your endpoint if your endpoint contains like if user has role, it's probably bad idea. It's probably something went wrong. You should not have been doing that, but you can technically, but don't. Unless you have a very good reason for that. Request signatures. So this is an important point, right? Because until now, we've been looking at authorization and authentication, making sure that whoever runs stuff has permission to run it, and you know who that is, right? But in this case, we also want to make sure that the request itself has not been tampered with. You don't have a kind of a man in the middle kind of attack where somebody catches the request, modifies it, and passes it on again. So here you can actually sign your request and provide signatures of those requests inside that need to be verified before you can actually process it. This is for quite high security kind of endpoints and stuff like that, but it is possible, and it's quite, well, relatively easy to do. Right here, it's a typical use cases would be when you have some kind of webhook receivers, or you need high security on your endpoints. Right. And the examples are, again, like here, you can click on each of the examples and have a look at the docs and the code of the whole thing. Right, let's move on the third feature. So third thing is a lens. So lens is it's about observability, it's about health, it's about providing information about how your application doing, but it is not necessarily exactly logging. Observability is not equals does not equal to logging, because logging is just like it's just, you have to have that, but observability is more than that. You can for example, inject into your applications, into your requests, a request ID, and you can do that in this way, right? Quite simple. If you just check if your request has a specific header. If it doesn't, you just inject it and you pass it on. Now you can use telemetry and everything of the whole thing, and trace all your calls with, for example, a correlation ID. So tracing filter and open telemetry span and all this kind of things, you can be also found here as well. So let's talk a little bit more about tracing. So tracing is a kind of way where you can enrich your open telemetry spans with domain context, so add more information to them, not just an ID, but you can also, for example, say you want to add a API version, or you want to add some kind of a resource ID or correlation ID and end user ID and things like that. You can do this as well. So this is an example of how you can do that. You can also will give you an opportunity to search by those kind of things, right? Search by version, search by entity, and so on, so on. So you can actually have a look at on the other end of your OpenTelemetry receiver based on different attributes. So another thing is that if there is no OpenTelemetry agent, you can just, well, nothing happens. If it is there, it will actually collect it, and this is a standard OpenTelemetry API that we're using here, that is implemented here, so it doesn't really matter what kind of collector you're using. As long as it supports that standard, it will be fine. Right, and in my case, I'm using Jaeger in a Docker container that you can also find in the repository, so you can actually start it up with Docker Compose and start my application, and it will kind of start collecting that information on its own. Pretty cool. Right. Another thing that's important to think about when we're talking about the lens is that we need to have a liveness checks. So liveness check is something that makes sure that your process and your application is still alive. It will, after your application has been booted and has been running for a while, it might ping that endpoint from time to time to check if it's still alive. Your platforms like Kubernetes might need it to understand if the container is healthy or if it needs to be terminated and restarted, and so on, so on, so on. Right. So that is liveness checks, but there is also something called readiness checks that we'll talk about in a second. But here it's important to mention. So we do add liveness here, and if you want to have a look at a more kind of in-depth example, this is in a different repository from a different talk that I've been doing for some time now, about talking about 5 features that cloud native applications should have, and you can find the URL to that folder, to that package where all this health implementations, health check implementations are. It's a bit long URL, but you'll have the presentation, and then you can actually just click on it and get right to the correct package. Let's talk about readiness checks. So readiness check is a bit different. So until now, we've been checking if application is up and running and if it's healthy and it's doing fine. Now, this one is a bit different. This is something that is being run in the beginning to understand if things like Kubernetes, for example, can route traffic to your application or to that instance of that application, because for example, will check if the data is loaded, if everything is up and running, if you're actually ready to process those requests and give something meaningful back, instead of just like spin and wait. You can do that as well. This is a very simple implementation of that, but you can also have a bit more. So at readiness, that's the annotation for that. But if you really want to have a bit more comprehensive example, again, the link is at the bottom. When you run this repository and you've compiled it and run everything locally on your machine, you can actually use those curl requests at the end to actually see how it works. Like I said, we will probably won't have time to do all the demos live, but again, everything is there for you to run as well. And please send me bug reports if there are any things that are not exactly working the way it's supposed to work. Okay, let's talk about one more thing. Another important thing here, the fourth feature or fourth thing that I want to talk about, it's a living contract. So it's an open API spec that you can make sure to use to create your documentation, or to keep your documentation as close to your code as possible, because it's a very important thing here as well. You want to keep your documentation as close to your code and regenerate it whenever code changes, because otherwise they will drift apart and they will end up being in two different states, right? You have a documentation that's super old and you have an API that's very, very different. You don't want that to happen. And the code is the contract, right? This is a very simple, again, example. There are much more complex versions of that you can create, where you can document all parameters, document all information about this. You can also document all the possible error codes it might give you, or all the possible OK codes it can give you, and so on and so on. So it's a very, very, really nice way to build a living and very comprehensive contract that, for example, Swagger, that is built on top of OpenAPI, can use to generate the nice graphical user interface for you to test those APIs if you want to. But there is one thing. So sometimes you have a certain things that you want to add to your APIs without needing to add it to all of them. So for example, you want to add request ID to all of your calls, and instead of copy pasting it to all of everywhere, you can do something smarter. Or if you want to have a global 500 error response, or if you want to do some kind of organizational wide standards for something else, you might want to look at OpenAPI specification filter called OS filter, that will help you to do this kind of thing. So code example for that might look something like this, where you will be, here's the actual code for it, right? So the code can look something like this, where you create, for example, you add to a header X request ID, and also you add a 500 error, for example, right? Again, you can run it with this curl command and see how it looks on your machine, if you have your application compiled and running from this repository. Last fifth thing that we would like to talk about is the evolution of your API. So your APIs will evolve through time. You will need to create versions of it. Otherwise, you will end up breaking compatibility with previous customers, with previous customers using previous versions of your API, and so on and so on. So in an industry, in an enterprise world, this is a very common problem because you need to have those. Otherwise, you'll have very angry users that where you keep on breaking the compatibility all the time, and they will need to change things in a bit more unmanaged way, let's say this way, right? So there are three ways of doing that. You can do versioning with URL based. That's most of you probably have seen throughout times. This is the most visible version where you put a version inside a URI. You can do say API v1 sessions and v2 sessions and so on and so on. It's very explicit. It's easy to cache. It's easy to test. It's easy to see and follow, right? It will create multiple URIs for the same resource, and it will create a bit kind of noisy kind of thing. You can also do versioning based on headers. So inside your header, you can say XAPI version, for example, 2, and that will be also handled as a different version. So it's a different way of doing that. You'll have the same URLs, no versioning in the URL, but you will, so it's easy, it's cleaner, but it's also a bit harder for us humans to actually understand what's going on. Now we have to inspect the headers as well, but it can be very, very useful. Very often you kind of end up combining URL and header based. We'll talk about that in a second, but this is number way of doing it. Number two, and number three is using media types. You can also use media type to provide different versions, and then you can also handle several versions, annotated with several versions for the same method that will catch them and process them in different ways. For example, for session version 1, you had a flat foreign key IDs that would be like, for example, speaker ID, while with version 2, we wanted to insert the whole object in there. So now we have a nested object, so it will be different. So this is typical example why you might want to split in different versions. If you want to see again all the three versions, this is a list to exact class where I do it in a different repository, but then you can also have a look there and understand how things work there. Right, so the routing. What you can do, it's quite fun. You can combine URLs and headers. So for example, here you look at the header, and if you see that the version is something, you can actually route it to a URL with that header. And it's why you want to combine those, you might ask. Well, it's sometimes you need that. Sometimes it's actually, you will see that in quite a few large systems, large enterprise APIs happening behind the curtains, and also you will see that the filter, that kind of filter can normalize header versions without really needing for you to create on the back end, behind the scenes, like different entry points. You can actually route everything through the same thing. For example, if you're standardizing on the URI-based versioning internally. So one routing mechanism, two different client options. So clients can do different things, which is really nice. A quick demo, well, which is not going to be a demo, but at least a way of running the demo is that you can do curl sessions and provide version 1, and you will see that speaker ID is just a flat attribute there. But for version 2, it will be a speaker.id, speaker.name, and .company, and so on, because it's going to be a nested object all of a sudden. And also you can see that you can provide, instead of doing the URL based thing, you can actually provide just a header, and you will see that you will be routed to version 2 here as well. Right. Okay. Final thing, a little bonus that I wanted to give you all at the end, after those 5 features that we talked about, is to how to handle errors. So handling errors can also be quite challenging and very, well, I don't want to say very often, but it did happen quite many times where you would end up leaking. No, not you, but I mean, when you will end up, let me rephrase that. When you will end up using an API where the provider might end up leaking some kind of information about what's happening behind the scenes in their APIs. It could be a language, it could be versions, it could be the versions of something that it runs on, and so on, and so on, and so on, or stack traces, the names of the objects and classes, and just let you understand what it is, if it is Jakarta EE, or maybe something else, or maybe different language even, right? To do that, you can actually create a standard error envelope that will kind of catch them all and return the one specific error, for example. There are standards for that. So there's like RFC 9457, for example, and every API does not need to invent their own error format. Clients really hate it. Just keep it to the same error so it can be handled properly by the systems that can show logs and can do all these kind of things in the same time as well. So keep it to the same standard, and content type is application problem JSON, and then here is the problem detail class that we've created for this talk, so you can have a look at this one as well. And what you can do also is you can map those errors, exceptions, to different error codes. So for example, in this case, you don't need well, in all cases, you don't need any try catches ever. You can just throw exceptions, and then you map those exceptions to proper error codes. And if there is anything that is unexpected kind of exception, you can map it to a generic one. So here are some examples of how you can do that. For example, with the things 400, things 404, so not found exception, or constraint violation exception is 400, not found exception is 404, not authorized exception is 401. What else? Forbidden 403, and then at the end you have like gotta catch them all kind of exception, where you catch all exceptions mapper into a generic 500 error as well. Again, all of those code examples are available. You can just click on them and have a look. A little bit about testing strategy. That is just what you will see in this repository rather than what to expect from a API. But I kind of do expect from your APIs that you have proper testing. But in this case, I have both unit tests and integration tests to make sure that things that I'm talking about are actually testable. Then you also have test isolation things, where I've created a class which will handle different, so it's a singleton container, but also which will handle different runtimes, because all the code that I've shown you can run Quarkus, OpenLiberty, and Halidon. Doesn't matter, because that's was one of the aims of this talk, is to make sure that it can run on any runtime and it's generic enough to be recognized, and you're not really kind of locked into one vendor or another. So here you can actually have a look at different ways of doing that. Here I'm, for example, generating live on the fly different Docker containers to run for different, based on whatever, so Liberty image, Quarkus image, Halidon image, and so on, so on, so on, right? Which is really nice. You can also run all the tests with the run test and Maven test, Maven verify with different profiles for Quarkus and so on. And at the end, just a little quick recap. So we have looked at gatekeepers, so all kind of filters and things related to that. We talked about security. We talked about how to observe your applications, observability and health, and all this things related to that. We talked about living contract and OpenAPI spec. We talked about versioning, and we had a little bonus on error handling as well. So with this, it's time to say thank you very much, and also share the link to the whole presentation and the code that you have seen here. It's everything is in that repository. Inside there, you'll find /presentation. That's where you'll find this presentation, but also the rest of the code as well, where usually the code is. The more other repositories that I mentioned in this presentation can be found here. And if you really want to find all my GitHub account, my social media accounts, and everything, go to Rustam.no. Rustam.no, that's where all the social media links, all the GitHub accounts, and everything will be, and then you can just use that to navigate around. So thank you all for joining. It's been a great pleasure doing this talk for you today, and I hope to see you at some other event somewhere around the world. Bye-bye.